Hello, everybody. This is Emmy Williamson from Flow Theory 101. Today, I'm going to be fixing my lathe that broke down. It's a shop lathe that I bought about 8 years ago, and it was kind of an inexpensive small lathe, but it's a little expensive for me to replace right now. So I'm going to try and fix it myself. And the problem is, I'll give you a little rundown background here on what's going on with this thing. The main control unit that's used to turn it on and off and control the speed has a circuit board in here that's bad. You can see this capacitor blew out. Two capacitors here. It's got some transistors back here, and this is the variable direction switch. It goes right here. You can see it says reverse and forward. The switch is going to go there. It was there. I just took it apart to do a diagnostic and find out what's going on. This is the speed control knob, and it was right here where it says RPM. And that is actually bad. It's going to have to be replaced. This circuit board, I was considering resoldering a capacitor in here, but power supplies are fairly inexpensive and easy to obtain. I was able to sneak around here at Solar Snap and find something that I can use with this speed, this power supply. It's a 24 volt power supply. Now this ran off of 30 volts, so it's need a little bit of power, but I found this adjustment pot right here on the board, and I was able to turn it up to 26 volts, roughly 26 volts. So let's turn this on and see if it works. This is the motor back here. It had this pulley, which was really cheap, and the teeth had worn out. So my employees put plumbing tape on here to try to make it work better. I don't know. I guess apparently it was working, but I found this nice aluminum pulley, and I installed that last night, and it seems to be working. And this power supply seems to work okay. Provides enough power. I think I'll be able to make that all work. And then what I'm going to do, these are the old components. This is what it looked like when it was new. Variable speed mini lathe. These guys are just gonna come out of here and probably be thrown away. I'm gonna probably use this board here. It's an aluminum heat sink. And here's the thing, here's the point about this whole thing, why I'm doing this. Why I'm doing this is because, I like a lot of people, I want to be able to work on my electronic stuff and do electronics myself. And, you want to be empowered and understand how these things work. But, what I'm learning from doing these little projects is a lot of times it comes down to, applying your intellectual creativity to try to find solutions. So by substituting in this power supply and hopefully, fixing the other problems related to this, like the pulley and the speed control, I'm hoping that I'll be able to put this thing back together, in a reasonably professional way. Here's the control box again. This mounts right here. This just goes up here like this. I'm going to try to repair some of this and make it a little bit better. And then this board, I'm hoping I can just fit this board in here. Now, that's power, and that board, it'll fit in here no problem. But there's another major problem, and that is I have to be able to control the speed. So I have to be able to change the voltage in order to do that. Now I have a lab power supply here, inside here. This is the power supply I used to test it before I found that power supply that's on it right now. And by setting the voltage between 5 and 28 volts, I was able to get the full range of speed that I had before. So, and that's really important when you're working with the lathe. You want to be able to slow it way down sometimes. You want to be able to speed it up. You need to be able to turn it on and off. You like to occasionally reverse the direction. Now this is DC, so that's nice because then reversing is really easy. All you have to do is flip the polarity. Now I'm thinking that I can use this same switch that was in there in the original, machine, and just wire it so that it reverses the polarity of the wires. So plus becomes minus and minus becomes plus. So that should solve that problem. But still, we're back to the problem of how do we change the speed? Because this power supply, although it's a quality, reasonably good power supply, it has no way to change the voltage. It outputs a constant 25 and a half, 26 volts. So what am I going to do to fix that? Well, and here's the part about the video I wanted to share with people so they can start to maybe expand their horizons a little bit, as I'm trying to do here with this, is we have transistors. And with the transistor, what you can do is you've got 3 legs here. You have electricity coming in and going out to whatever the thing is that you're running, and you want to be able to change the voltage. Okay, and the way you do that is you vary the voltage coming into this pin. So what I want to do is I want to take the voltage coming out of that new power supply, and I want to vary the voltage going into this leg right here. This is called the gate right here. This is the gate. This is called the drain. The middle one is called the drain, and the rightmost one is called the source. The electricity comes in the source and it goes out the drain, and then you use the gate, like you open and close a gate, to get in somewhere. That's kind of the principle is you can vary the voltage between 3 to 5 volts with this particular transistor, and they're all actually, that's kind of a standard voltage for regulating that. And you can change the output of the transistor. So the transistor is going to output the power to the motor directly. It's going to come out of the power supply and come in here, and then it's going to go out this middle pin and go to the motor, and then hopefully we'll be able to vary the speed. So that's kind of the big, trick with this whole project for me, is to try to figure out how to do that. Now with this nice board we've got here, let's see these transistors that I have, I can actually put them on the back here, because with a transistor you get a lot of heat sometimes off of this post right here. So what I need is a good heat sink, and this is the heat sink that was in the original unit. So if I can retask this heat sink and put my transistors here, and then my plan is to install them in parallel, so that it'll raise the amperage or current carrying potential of the whole thing, so that it can carry the amount of amperage or power, total watts, that this motor is going to require. So if I put them in parallel, then they carry the load together, and that will allow it to hopefully have enough power to drive the motor. But that's sort of, for me, the challenge for this project. So I hope to report good results. I'm going to do this in 2 videos. This is the first of the 2 videos, and I'll upload another video to show the results and how this all came together and hopefully worked. So that's it. That's the project, and hope to see you all in the second video where I actually demonstrate it functioning. Thanks for checking in with Flow Theory 101, and have a great day.